So the next thing we're going to talk about is how to program some of the ring molds or jewelry molds using 3-axis toolpath methods. So I'm going to go ahead and save this file in here, and we'll go ahead and locate another file to work on it for programming a ring mold. Okay, so what I have here is 2 halves of the mold, a ring mold, and the left half and the right half, or you could call it the top and the bottom halves. And I also actually have the ring model in here, as you can tell. So basically you can create your ring design and then do the Boolean operations to create the mold half, 2 halves of the mold. So I'm not going to go into the details on how to create the mold halves. I'm sure you're all familiar with it and how to use in your CAD systems. This could be done in your CAD for Rhino. You could be doing it in SolidWorks. You can create these designs, or you could be using any CAD system of your choice, and then you can import those designs into it. So I actually have the ring model and also the actual mold halves. I'm going to go ahead and hide these in the layers. So we'll focus on programming one half of the ring mold in here. So as you can see, the ring mold has been created, and we have the 2 halves of it. So I have these pins and pockets, so it lines up correctly when you put the 2 halves together. So first we'll program the first half in here, the ring mold. So the workflow would be very similar to how we programmed in 2.5 axis. So we would go through the process of defining our machine tool, selecting the post processor, and you want to make sure you've established the orientation correctly in here. So in the next step,
Uday, I just want to interject here. For those people who are very familiar with machining models, wax models, what we're actually seeing, I would like to talk a little bit about the process. What we're seeing, there's molds for creating wax models. So you would create a typical, this is a master mold, if you will, and that's used to create a wax model that you would then put it up in a tree and to create the investment casting. So this is one of the processes that a jeweler would typically go through to create the model, or the master model, or rather the wax model of a jewelry item. So I just wanted to bring that to your attention. Thanks, Uday.
Thank you, Joe. So in this particular part, we have both prismatic features and also sculpted features, where you have pockets with sculpted floors, and so parts like these can be programmed using a combination of both 2- and 3-axis operations. And the first step in here is, again, establishing your machine, your post-processor, and then let's go ahead and build a stock in here. So I'm going to go to box stock. We'll do a copy model bounding box. You'll notice that the length, width, and the height have been established in here. I'm going to pick OK to accept it. So I've defined my stock geometry. When you go to the Simulate tab, you'll see that the stock model has been defined. Now, if you're going to be programming this part on the 2 halves on 2 different vices on the same machine tool, you could be using your fixture offsets. You could create a work zero for each of these mold halves, and you can establish them by creating a work zero by specifying set to stock. You could do highest Z. In this particular step, I'm going to pick, again, southwest corner, and then I'll output this as my work offset number 54, so G54. Now for the other half of the mold, I could be using a G55, which could be my second work offset. So I've established G54 for the first half of the mold, and in the next step, I'm ready to program some of our toolpaths in here. So we'll start with first, pocketing these holes in here. So I'm going to use a 2-axis. I'll start out with just a 2-axis pocketing operation. And I'll pick these face edges on top of these holes. In the next step, I'll make a selection for the tool. So I'm going to use a 1/8 inch, which is basically about a 3 millimeter flat end mill. Again, specify feet and speeds and clearance. In the cutting parameters, you can establish your tolerances, cut parameters. And the cut levels, I'm going to choose determine using 3D model, and I'll specify my depth per cut to be 1 millimeter. And leaving all the other parameters at the current default settings, I'm going to pick generate. And we now have a pocket toolpath. And since I chose determine using 3D model, you'll notice that the total depth was automatically determined based off the 3D model, so I didn't have to go and pick the 2 points like we did on the previous example. So you could use determine using 3D model to establish your depth. So now let's go to the Simulate tab, and then I'm going to run a verification in here. So I'm going to leave the stock color for this particular simulation in the default color, so we'll apply a different color for some of the other processes in here. Now I'm going to switch back to the Program tab and start out with a roughing pass. So I would like to rough the cavity on this mold, so I'm going to use 3-axis and horizontal roughing. Now this method, roughing, is available in all of our configurations: Standard, Expert, Pro, and Premium. We'll start by selecting a boundary in here. So I want to contain my toolpath just to the cavity of the mold. So I'm going to pick this boundary. It could be selecting a chain of face edges, or if you have a curve or a sketch boundary, you could select that. Right-click or press Enter to accept your selections. I'll still go with the same end mill for the roughing process. Establish feeds and speeds, clearance, and then we'll go down to the cutting parameters where you can specify your tolerances, your stock to leave after it's being roughed out, a cut pattern. You can specify in the cut levels, you can specify your step down controls. Engage in retracts can be set under the Engage in Retract tab. So when you engage in material, when you have cavities, you want to ramp into the cavity, so you can specify the parameters for it. And any advanced cut parameters like arc fitting, perform smooth cut connections. So once you establish these parameters, you pick Generate to generate your toolpath. So now the roughing operation has been generated. So I'm going to go to the toolpath visibility to display the toolpath. So as you notice, the cutter was unable to get into some of these tighter areas because the cutter was too large for it. So we would like to go back and reprogram this using a re-roughing operation. Now before I program a re-roughing operation, I would need to run a verification or simulation. So I'll go ahead and assign a color for the simulation. So I'm going to change this to a different color in here for the simulation for the roughing, and then select play to run the verification. So we now have the roughing operation being simulated. Now once the roughing operation has been programmed, I'm going to switch back to the Program tab from the Simulate tab, and we'll add a re-roughing operation, so horizontal re-roughing. Now the horizontal re-roughing is part of the advanced 3-axis module, which is available in Pro and Premium configurations. So if you are running Standard or Expert, you can, if you'd like to get some of the advanced features, you're welcome to call us, and you can find out more about how we can upgrade to the the Pro configuration. So for this particular process, I'm going to go over and select a 16th-inch end mill, specify feeds and speeds and clearance, very similar to how we did in the roughing process, and also establish our parameters like the tolerances, stock, cut patterns, cut directions, step overs, cut levels, and engage in retracts. Now the re-roughing operation takes into account the in-process stock, which means the stock that's being left from the previous roughing operation to establish the areas that needs to be roughed. So it's not looking at the initial stock that was defined, it's taking into account the stock that's being left from the previous step. So as you notice here, it's only creating a toolpath where there's material that's being left from the previous process. The re-roughing knows the in-process stock being left from the previous step. So we now have the re-roughing operation programmed, and let's go ahead and run a verification for this in here. So I'm going to pick a different color for the simulation, and we'll select play to run the verification. So you'll now notice that the material is being removed in areas where the larger cutter could not get in. So this is a very efficient way to program it to reduce your machining time and make your programming workflow a lot more efficient. So once we have the re-roughing program, I would like to go back and program a pre-finishing and a finishing toolpath. So this could be done using a variety of different methods. I'm going to start with a finishing method called horizontal finishing in here, which is also known as finishing in levels. And I'm going to pick this boundary for containment. Now for the tool, I'll pick a taper tool. Again, in this particular step, I'm going to use the 0.5 millimeter 2-degree taper tool for finishing. The feeds and speeds are being loaded from the tool. I'll leave the clearance to automatic and specify the parameters for cutting. The cut direction, I'll leave it as climb conventional, so it'll alternate between climb and conventional between levels. In the cut levels, I can specify my step down. I can use a % tool diameter, or I could even do like a distance, and I can choose the cut level ordering and specify any additional parameters like entry and exit and advanced cut parameters. Having all of this set, I'm going to pick generate. So in this particular process, it's going to generate a finishing in levels toolpath, and there's the Z-level finishing, or also known as finishing in levels toolpath, with a taper ball and mill. So I'm going to switch to the simulate tab in here, and I'll assign a color for the simulation. And then pick play to run the verification. So as you now notice, the finishing operation is in progress, and it's creating a pre-finishing or a finishing operation to remove the material to bring the stock as close as possible to the finished shape of the part. So you could be using a combination of different types of finishing methods. You could be doing horizontal finishing, which is offered in all of our configurations, starting with standard, expert, pro, and premium. And you could be even using a combination of this with a parallel finishing to achieve the result and the finish quality of finish that you're looking to achieve. Again, at any point of time, you can select pause and hit simulate to end to run through the simulation. Now, as you notice here with the horizontal finishing, since this method is called finishing in levels, as you get to areas that are not very steep, you might not be able to finish all of those areas. So to go back and finish some of those areas, you could be using a method like a parallel finishing in here to clear up material in these areas. So I could go back to the program tab and add a parallel finishing operation. This is also known as planar finishing. Can be great for use for near flat areas or kind of sculpted features. We'll use the same tool. We'll specify the step over in here to 15% of the tool diameter, and then I'll pick generate. So this is also a very commonly used way to finish. Now, if you want to exclude these flat on the top from being machined, you can edit the parallel finishing operation and add this as your containment region as well. So the toolpath will be generated between these two areas. So we now have the parallel finishing operation programmed, and I'm going to go back and run a verification for it again. Again, folks, if you do have any questions during this webinar, you're welcome to post those questions in the questions panel, and we'll try to get them answered for you. Now, once these pre-finishing and finishing operations are complete, we could go back and add an additional toolpath to clean up some of these scallops that are being left around these areas in the part where you see bitangencies on it. So we could be using a method like a pencil tracing or a remachining operation to clean up some of these areas. Now, the methods pencil tracing and remachining are again offered in our Pro and Premium configuration, and those are part of our 3-axis advanced module. So here what you're seeing is the progress of the simulation of the parallel finishing operation. So once this has been completed, I'm going to go back and create a final finishing cleanup operation using pencil tracing. So we'll go into 3-axis advanced, and I'll pick pencil tracing. And again, with the same set of boundary regions selected and with the same tool selected, I'm going to generate a pencil tracing operation in here. And this is going to look at the part geometry and look for all those bitangencies and create a toolpath to go and clean up those areas to result in a nice finish on your mold cavity. So depending on the complexity of the part, complexity of the the type of tool that you're selecting, the computation time could vary from a few seconds to probably a few minutes. So it's doing a lot of processing in here. And there's the pencil tracing toolpath that's being generated. As you can see, it creates a nice path to clean this up. So let's go to the Simulate tab. I'm going to pick a different color in here for the simulation. Now you could have assigned the colors based off the tool, so I wouldn't have to change it for each and every operation in here. So I'm going to select play, and you'll notice that the pencil tracing operation is cleaning up those areas. So now the mold cavity of the first half is ready, programmed and ready, and is ready to be post-processed out to your machine. So you can just click on the setup one, right-click, and then select post to post-process this out to your machine. And you could be selecting the post-processor that you'd be using for your machine. In this particular step, I'm going to pick a FANUC controller. I'll just post it right to my desktop. And there's the posted code, and you'll see your G54, the work offset, being output right in here. Now we're ready to program the second half of this mold cavity in here. So I'm going to display the visibility of the mold cavity number 2 and hide the cavity number 1. Now you could be programming this using another fixture offset. It could be like a G55. Now one of the things you could do here is you can group all of these operations what you programmed into a MOP set, like a machining operations set, or you can put it under a different setup. So if you're using standard expert, one of those configurations, you can group these operations for the cavity 1 into a MOP set. So by selecting all of these operations, you can drag and drop them into a MOP set. So when you select the work 0 and MOP set and post it, you're posting the mold cavity 1 with the work coordinate offset. Now I can make a simple copy and the paste of the same MOP set in here, do a copy paste. I could do Control-C, Control-V to copy paste, or right-click and copy and paste. And I'm going to insert a new work 0 in here. I'm going to insert a new work 0 after I define my stock geometry for this particular model. So I'm going to go back and define a part box stock in here. Now my stock is defined, and I'm going to add a work 0 for this. So I'm going to click on work 0 and set it to the stock, highest Z and southwest corner. And I'm going to pick this as my G55 as my work coordinate offset. Now once I made the copy of this machining operation set, I'm going to place this under the new work 0 as you notice it. So I can reuse most of these machining operations in here to program the other half of the cavity. So I could be programming a roughing operation to machine the cavity on the inside. Now before I program the roughing, I would like to program the areas around these pins in here. So I'm going to start by programming a 2-axis and a roughing operation for that. So I'm going to select these features on the top edge of the pins. I'm going to use that as my part regions, specify the cutting parameters for the 2-axis roughing operation. Under cut levels, I'm going to specify the bottom of cut to be right over here and generate. And that's going to be, say,
just a note on the roughing operation, it's a little bit different from the pacing and the pocketing operations in the sense we use the stock model to figure out the extents of the cut. So we automatically figure out the extents and then use any containment regions to stay off of, as you can see here. Thanks, Uday.
Thank you, Joe. So we now have the roughing operation programmed in here. So this is very similar to roughing in 3-axis. However, here, you're using a roughing for 2-axis operation ideal for prismatic parts. And as Joe pointed out, this automatically takes into account the extents of the stock that you defined. In this particular case, it just happens to be a rectangular stock, but if you're using a stock with any other shape, cylindrical or any odd shape, it'll automatically take that into account. So in the next step, we'll go back and program the roughing operation in here. So we'll just go back and reselect this region for the cavity half number 2, generate the toolpath for it. And likewise, repeat the same process for the roughing and then the re-roughing operations in here. So I could go back and I can also specify the parameters for each of these steps. So the roughing operation has been programmed, and now I'm going to go back and program the re-roughing operations by using the same set of containment boundaries in here. Now since I copied and pasted the entire setup of operations, you'll notice that the properties including the simulation, color, the tool, the feeds and speeds, all of them are transferred over automatically. So I didn't have to go through the process of redefine them and recreate them. All I'm doing is dropping the initial set of machining region and then selecting the machining region from the other half of the mold cavity in here. So this would be a typical process of how you would be programming roughing and finishing operations for 2 halves of a mold cavity. And finally, I would be programming the pencil tracing operation as well once I'm through with the parallel finishing operation on it. So this would be for a cavity mold for a ring. You could be working off of a cavity mold for like a pendant, pendant design. So here's an example. What you're looking at is a cavity mold for a pendant design where you have operations like roughing. You have, clear flat tops machining operation to machine all of these flat areas. You could be doing re-roughing operations and finishing using, a variety of different finishing methods. And here what you're looking at is a 3D offset pocketing. So just to give you an example of how you can use a 3-axis methods for programming molds and mold cavities for different jewelry applications in here.